So now it's time to Franky Weber Faust. Franky, if you can share your screen right now. Perfect.
Thank you. I was trying to unmute myself.
Okay.
All right. So you hear me okay?
Yes.
Okay,
Clear.
perfect. All right. So we are already on time, right? So I can get started.
Yes.
You can see my screen, right?
Yes. Now it's loading the presentation mode.
Okay, perfect.
Now I will mute myself and go on.
Okay, cool. Thank you. Thank you, Nikki. I'm following up on mine now. Okay, so the title here, cheating your application code with the Oracle database. So the idea here is to cheat the shitty code of the database developers or the application developers. The idea here is to be a cheater and use database features to actually overcome issues that we face on ugly SQL code that we find everywhere. So my name is Franky. I'm a senior Oracle database consultant at Python. I also have Exadata training on my own at Laura Data. I'm 29 years old. I usually write for OTN Latin America and on my blog, and also you will find some articles of mine in Python blog. Also a board member of the Brazilian Oracle Users Group. I have spoken at some conferences around the world. Started my speaking engagement in 2016. So it's pretty recent. I've been to Bulgaria twice, presenting at the BGOUG conference there, to Vancouver in Canada, Santiago in Chile, and most recent September last year in Wrocław, Poland, and again Bulgaria. So as I mentioned, twice in Bulgaria. I consider myself a high availability specialist because this is the subject that I started getting interested at first, but I also research a lot on database and SQL performance. So I'm always learning, and you will notice that my knowledge are more related to Exadata, real application clusters, DataGuard, and Golden Gate. I'm also an acro yogi. So I practice acro yoga with my wife. I like to tell that to people because it's a good thing. It's a nice inspiration. So maybe you get inspired and have fun with that as well. And on my free time, I'm also a guitar player. Actually, I don't have too much free time recently, so I don't practice a lot. I have some certifications. It's not up to date here. It's I think 2 missing. And I'm also part of the Oracle ACE program. And you can find blog posts that I write on at lardata.com.br. So I'm from Brazil. Despite the name, Franky Weber Faust, I'm Brazilian. So let's move on. Oh, actually, this is acro yoga. If you are interested, this is myself and my wife practicing around the world here. Here you have all my social media. You have my email, my PTN email, and my company's email, my blog, Facebook, Instagram, Twitter, LinkedIn, and Oracle ACE profile. So you can find me everywhere. And if you have any doubt regarding this presentation, or if you want to get in touch, just connect with me on any of these social media. So Python is 22 years in business in more than 35 countries. We are more than 400 experts around the world. And we have, I think this is outdated. I think we have more than 600 clients now. So yeah, it's actually more than 350, right? So anyway, so what Python does, we help business transform and win using data and cloud. So if you have any questions or any inquiry about that, you can get in touch. So why this presentation? So why I decided to do this presentation? So in the beginning, when I was starting to think about a new presentation to speak at conferences, I came with the idea that sometimes people don't know many of the features that we can use in the database to trick some of the application codes that we face everywhere. So sometimes you cannot change your application code and you have to change something in the database that will make that query run faster even without changing it. So that's why I came with this presentation at the first place. So it's pretty easy. You just move your database to the cloud and starting using there, and everything will start running faster. This is pretty smooth. You just move your workload to the cloud. There is auto-scaling features. There is everything else that you can use. Autonomous database has self-tuning, self-patching, self-securing capabilities. Your database will run faster. It's pretty easy and smooth. So that was a quick one. If anyone has any questions about it, it's time to ask, or we are done with the presentation. Okay, no questions. Thank you very much for your time, and sorry for the bad joke. So let's get started. So I have a small agenda here. I'm going to talk about SQL optimization techniques on technique to tune the application client, and we'll see the difference on tuning those clients. We'll see some examples on connect, commit, and binds. So we will see application connecting on a non-optimal way to the database, committing on an optimal way to the database, and also not using and using binds. And we'll see the difference between each execution. And if we have the correct application in place, we'll see the difference on the performance. So that's what we will see. So what is actually available to help you to cheat your code out there? So you have many features that help DBA or the database itself to overcome some SQL, some ugly SQL or non-performant SQL queries running on the database. So sometimes you can enable cursor sharing. There are situations where you can change the commit wait parameter to no wait. So there are specific situations. There is a new feature introduced in 18C called mem optimized row store fast lookups, and in 19C fast ingest. So we will actually, I have it here in the presentation, but we won't get that far. We have advanced rewrite, we have neutralized view rewrite, SQL profile, SQL patches, parallel execution, result cache, baseline, which is SQL plan management. We have advanced compression. If you are running on Exadata or Supercluster or ZFS, you have hybrid column compression as well. You have partitioning, function-based index. You can use reverse key index, clustering factor, append, and the append hint, and no logging hints. You can use text index for where like clauses. Dynamic sampling can also help you in some situations. And you also have in-memory column star. So there are a lot of features available. We won't be able to cover all of them here. Obviously, it would require a lot of time. But I would like to go with some techniques that I found it useful that I could show here. So I ended up with this small list. which we will see on techniques to optimize the SQL or the database running that SQL by altering the access structure, altering the environment, altering the SQL statement. We will see SQL rewrite, we will see some hints, stored outlines, SQL profiles, SQL plan management, and compression. So the ones that I like the most are the alter the access structure, alter the environment, alter the SQL statement. I put it here in red because sometimes that's not possible. So you cannot do, sometimes you run a third-party application and you cannot change the SQL statement. So it would be easier to overcome that problem using the database features instead of changing the SQL statement. So we will see some examples. SQL rewrite, it's a very nice feature. Hints, they are good, but they shouldn't be used on any application code because the data changes, and if you don't change your hints when the data changes, they will get stuck there, and probably they are forcing the cost-based optimizer to choose a non-optimal execution plan for that data that you are actually querying. So hints are good, but they shouldn't be used in any application code. That's my my personal opinion. So you have also stored outlines available to you. We won't see them, but it's available and it's for free. And the last three ones, they require compression, and that's why I put them in yellow here. So SQL profile requires tuning pack. SQL plan management, if I'm not mistaken, it also requires tuning pack when you enable a SQL plan baseline. And compression, also advanced compression. So those are cool to use, but requires extra licensing. It's worth to check the license manual because I'm not a licensing expert on those matters. So worth checking the licensing documentation. So by altering the access structure, what do I mean by that? So basically, when you alter the access structure of a SQL statement that you want to run, it's basically changing the indexes to some different type of index that could suffice the query that you are running. So let's say you can change the index that you have in place now by a function-based index, because instead of, I don't know, you change something in the application, I mean, not you, but the developers or the third-party application owner changed the application, and now all your, I don't know, queries are using upper and lower functions when searching for names, and all the index that were in place are not working anymore for that specific query. So there is, now it's time to change for the FBI index. Reverse key. So sometimes you have, let's say, buffer busy waits and index contention on your database. So let's say it's a very high transaction OLTP application running, and you start to see buffer busy and index contention. So maybe it's time to use reverse key index. So everything you can. This is something you can change on the database and not on the application code itself. Sometimes it makes sense to use bitmap indexes. So let's say you are running, I don't know, a BI application or OLAP application, and it makes sense to use bitmap indexes because they are a very small structure. So bitmap, they are very, very small, and that's why they are fast. It's not because they are faster than B-tree. B-tree, I mean, there's a difference on the architecture on the index, but bitmap is mostly faster because the index segment itself is smaller. But you have to be careful because bitmap can lock the entire set of rows that you are querying, or actually not querying, but changing. So if you're trying to change something, some data that has a bitmap index related, you will lock that set of rows until you change you perform the change and to finish your transaction by committing or rolling back the transaction. Altering also the access structure means that you can create or alter or change your materialized views. You can implement materialized view rewrites. So that's what I mean by changing or altering the access structure. So the database can access a different structure for the same SQL query that you are running. You're giving other options to the database. So that's a way to overcome the SQL performance issues that you might face. And also partitioning. Partitioning is also a change in the SQL in the database structure. So you're giving another access method to the database. So those are, I would say, the most common changes in the access structure that you can perform. And I have to mention that partitioning is also extra cost feature. So if we're planning to use that, bear in mind that it costs extra. So here we have an example. We have a simple query looking for the first name, the customer ID, the customer first name and last name, and the email of all of our customers, where the customer first name is Reyes. So Reyes, all in lowercase, right? All lowercase letters. So if we check here, we have an execution plan, which is performing an index range scan using this IDX cust first name index. And the cost for this operation is 5,500. And if we check the time, it's under a second. It's basically 1 centisecond, and it's just doing 48 buffer gets. So it's pretty fast operation. So let's say now we got an application update. So the application was updated. They changed it to a newer version, and now everyone can search for the application users. They can search for the first name and lowercase or uppercase letters. So they changed the application, but they didn't change anything in the database. So now the database, we are searching for the same users, but we are using a different where clause. The same amount of rows are being returned. So you see it's still 44, but the cost increased from 5,500 to 32,000. And the execution got 89 times worse. And we are getting 120,000 buffer gets instead of, how much was that? Instead of 48. So there are a lot of reads going on, and the execution we are doing, the execution plan is performing a table access full operation in the customers table, just to query 44 rows. That's because we don't have an index on that where clause. Because this is a function-based index, we started using the upper function on this, and then if we just create a function-based index on this where clause, so basically you just create the index using this where clause here, and it will create the function-based index again. And if we run again this operation, the cost reduce a little bit, but we see a big difference on the buffer gets and also on the time. It's just 1 centisecond again, and just 48 buffer gets, and started using this function-based index on the customer name, customer first name column. This is just the index I just created. This is how we overcome some of these issues. So by changing the access structure. So that was just one example. By altering the environment. So what do I mean on altering the environment? So you can change system level parameters, or you can change the session level parameters using the logon triggers. So it's basically changing primary thing or changing anything on the environment that will affect the whole application or the whole database. That's what I mean by altering the environment. So here we have a simple SQL query. By the way, this is the swing bench order entry database that we are querying. So every table and data you see here was generated by swing bench order entry application. So I just used that to create some of these examples, and it's based on 19C database. So you can test yourself as well. So this is basically a query that's selecting all the products that were never ordered. So all the products, I mean, the product ID from this table, actually, I think product information, yeah, from this product information table, disconsidering these all the other item, all the product IDs that were never ordered. So all the products that are not present in the order items table. So we see here there is only one. So there is only one product, which is the product 991. And if we check here the execution plan for this statement, we see that there is no cost here in the execution plan. Why is that? So I don't see the cost here on my DBMS X plan output. So why don't I see that? That's because the optimizer was changed to use the rule-based optimizer, which is the old version of the Oracle database optimizer, which is still available and still used by internal database operations. That's when Oracle write their code, sometimes they use the RBO instead of the CBO. So I changed the whole environment here just to show you that by changing just optimizer mode to RBO instead of CBO, which is all rows or first rows, and I changed this to RBO, and we get this execution plan. Our query runs in 8 seconds, and we are not able to see the cost here because it's rule based and not cost based, so it doesn't show, it doesn't present here the cost here for us. So what if we change that optimizer mode to all rows? So now we see the cost column here. We see the cost of this operation. We see that it was changed to all rows, and you see that I'm using a hint here to perform a full table scan operation, because that's what was happening here with the rule-based optimizer. There was no hint, and it was performing a full table scan. So now I forced to run a full table scan with the cost-based optimizer, because if I don't specify anything, it will find the indexes and it will find that the cost is lower and it will use the index. So I just forced to let you know that it was running without using the index. But if you check, the time didn't change. So this is a damn shitty query that this application is running. So I see that it takes 8 seconds. If it always takes 8 seconds, or if it's included in the application, because here we are listing the products that were never sold, right? So maybe the company doesn't want that to sell that product anymore. They want to take this product out of their catalog or something like that to not offer anymore. So maybe this is a frequent query. It takes almost 9 seconds to run. And okay, it's maybe it can be optimized or not. So here I just changed to first rows 1. It won't change anything here because we're just querying one row. I just wanted to show here that even changing to first row, it won't change anything here. The cost will be the same, and the execution time will be the same as well. And here I changed the optimizer features enable. Okay, let's say you upgraded this database starting from 8.0.7. So you came upgrading this database since then, and then you passed through 9i, 10g, 10gr2, 11.1, 11, 11.2. You went to 12c, you went to 12.2, and now you got to 19c, but you never changed the optimizer features enabled. So if you didn't change, the execution plan, or actually the CBO will consider these optimizer features enabled to use features that were being used in this Oracle release 8.07. And you see that one of them is this internal, not internal, but underscore parameter here. So this was one parameter that was in place when Oracle 8 was the current release. So by changing the optimizer features enable, we don't only change this one parameter, we're changing the whole behavior of the optimizer, database optimizer. So you can see that it was also included here, the optimization group by elimination to true. So by changing just one thing, it changed a lot of other things. So you need to take care of with that. And here we have another query. So here we are querying other type of data, and this is performing a full table scan on this orders table and taking almost 3 seconds to run. And we see that the optimizer index cost ADJ is set to 500. This is a real case I got where I work. So index cost ADJ, it is how much an index will cost for the database to use it. So 500 is the non-default value. The default value, I think it's 100. So when this parameter is set to 500, the database, the optimizer is considering performing a full table scan instead of, and you see here the cost of this query, which is 72,000. So when we change this to most meaningful values like 30, we are telling the optimizer that to use an index, the cost will be on this 30 level. So when it creates the execution plan, the cost will be different, and it will start considering using the index. So there was an index in place, but it was not using because when the CBO did the calculation, it was considering that using the index will be more expensive than 72,000, and we changed that to 50, and the optimizer understands that the cost will be actually less using that index. So just by changing one thing in the whole environment, we see a huge improvement in the execution time. So the execution time here is 4 seconds, and it was almost 3 seconds in the previous example. So that's a good thing. Another example. Actually here I'm changing to the other optimization technique, which is alter the SQL statement. So altering the SQL statement is not always available for us. So it's not always that we can change the SQL statement. So depending on how the development of the application that you are working with is done, you will sometimes rely on a different team, or they have different priorities, or it's a third-party application that you cannot touch. So sometimes you don't have a way to change a SQL statement. But let's say that we are here looking for all the projects that were never ordered, so the same query as before. So we're doing a minus operation here between product information and order items tables. So we already saw these this execution plan before. So the cost here is 164,000 to run this operation, this SQL statement, and it takes almost 9 seconds to run. So if we change that, if we change the, let me just move this Zoom screen here to another place. So if we query in a different way, so we can do the same thing by running this query. So I changed it from that minus operation just to use a not in group set here. So I'm selecting all the products that are not in this select statement. So I'm selecting the product ID from order items. So I don't want a product ID that's not in the select statement that is present in the product information. So I get the same result, and it runs way more faster. So we see that it takes just 20 seconds to run. And the previous execution used to take almost 9 seconds. So it's more than nine times faster, right? So just by changing the application code, it's doing the same thing, the same specific thing, and running a lot faster. And we see that the cost to run this operation, to run this SQL statement, is just 2,000 instead of 170 something thousand. So it consumes way less resources. And if we check, this operation was using an index, but it was performing an index fast full scan. So it was running and scanning the whole index segment. So we just changed the SQL statement to something else, and it started, it created a different execution plan. It's still performing a fast full scan in one of the indexes, but the other is performing just an index range scan. So the cost is a lot less here, and the execution time is a lot less as well. Another way to run the same query. So I'm showing here 3 or 4 ways to execute to get the same results using different SQL queries. So I'm also looking for the product ID, and now I'm using the not exists. We see that the execution plan didn't change. It's the same execution plan as before. It's basically the same execution time as well. So we see that around 20 seconds. So it's the same thing as before. We just changed the query. And here is another example. So it's the same thing using a join method here. So in the background, it's doing the same thing. You see that the previous example is running nested loops and join, and here it's also nested loops and join. So it's doing the same execution plan, but with a different query. So in the background, Oracle does the CBO does the conversions for us, and we see that there are 3 ways to run with a good performance, and 1 way to run with a better performance. So the developer of this application chose to run, or maybe he knew only 1 way to run this query, and by changing this, we made it run 9 times faster. So we cannot change the application code, right? So what do we do? So how can you make this query? This is the original query with the minus clause here. So this cannot be changed. This is a third-party application, and we cannot change the query. So how can you make this query run faster without changing it? So what can you do? Can we do in the database side? So how can we make this run in under less than half a second instead of running almost 9 seconds? So we just change 1 parameter, right? So it's the same query taking less time, right? We just executed this query write integrity equal trusted. And it's basically the same thing as doing alter session set database speed equal fastest. So we wanted the fastest way of running the Oracle database. Yeah, that's not actually true. So I didn't show you everything here. So let's see the execution plan now. So the execution plan is doing the same thing as the other queries that we saw that were performing on a good way. So this is running the same SQL statement. We see that there is the minus clause here in our SQL statement. It's performing that nested loops anti-join. And the BMS explan show us the original query, but the plan is different. So same indexes, but a different approach. So we see here that the cost is 2,000 and not 170,000 as we saw in the previous example. So if we check the optimizer parameters, nothing was changed. Everything is the same. So let me go back just a little bit. So you see the database version here, the optimizer features enabled, dynamic sampling is disabled in this database. I use it in a disabled way, not to affect my execution plan when I execute it without statistics. So why now it's performing faster? I just changed one parameter and there is something else I will show you next. So nothing was changed here, but there is something called SQL magic you can call. So there is a feature that was introduced in, I think back in Oracle 8, so it's 20 years old already. So which is, the feature is called advanced rewrite. You use the BMS advanced rewrite package and you create an equivalence for the SQL statement. So you can pass your source statement. So the source statement is the bad one, right? And the destination statement is the good one. So every time the application, the user, or anyone in this database that's going to execute this bad query, the database will actually convert this bad query to this destination statement, which is the good query. So we do it, and we see that on these user rewrite equivalences or in the DBA rewrite equivalences, we will see the source and the destination statement. And when we do that, we feel like Gandalf, like when doing magic, right? Because the user performs the same bad query and started running faster without changing anything else, just creating a rewrite equivalent. So what I did here, so I changed my session to perform the rewrite, and I enabled CBO trace of the optimizer on this session. So this is the 10,053 trace, and I ran the query. I went, okay, it's executed in a good way. So with the trace enabled, I went to the trace file and started looking for what it did in the background to understand what happened and see how the CBO works with these kind of conversions. And then we see that the current SQL statement for this session was actually this one using the minus clause. So this was the execution that the CBO got as well. So when we started looking in the background, we see that the query block text is actually the same one that we see in the current SQL statement section of the trace. We see that the final query after transformations is the query after the rewrite was performed. So this is a nice thing. So this query, this bad query, the query block text that the user session executed was transformed to this good query here that we created in the rewrite equivalence. So this is a nice feature, SQL rewrite. Hints. So when we use hints, normally we are considering ourselves ourselves smarter than the CBO, right? Because we are telling the CBO what to do. So we are forcing a certain path for the CBO to follow. So hint is not actually a hint. You are not suggesting something to the CBO. So I would say that it shouldn't be called hint, but it's there for a year, so it's a hint anyway. So you're not suggesting something. You are forcing something. You are forcing the CBO to do something. It's not something that you are, okay, maybe if you do that. No, it's not that. You're not telling the CBO, okay, take that into consideration. Maybe if you take this index into consideration, it will execute faster. No, you're not telling that to the CBO. You are forcing it to use the index and performing the operations that you want. So here I'm forcing to use, maybe, I don't know, the developer of this application didn't like full table scans in the action plan, and not action plan, the execution plan. So it forced the database to pick up the indexes. So here we have the index hints to use the primary key for the order table, primary key, an item order index, it's not a primary key, another index in the address table, and another index which is the primary key of the customers table. So I'm forcing these operation to use those indexes. And we see here that the cost is 11 million. So it's a lot, and it's running this query for 2 minutes. So yeah, it's a lot of time to run this query. So we are forcing this. So without any hint, it's the same thing, but CBO decides not to use those indexes because it's considered it would be cheaper. It would be cheaper. The cost is only 245,000 to run this same operation without hints, instead of 11 million with the hints to force the use of the indexes. So not the table access full, the full table scan is not always your enemy. And the execution time is now, instead of 2 minutes and something, we are running in less than 15 seconds. So it's very, very faster. So when you agree with the CBO, you agree that you don't need any hint and the CBO is performing and behaving well. So I would say that hints, they are not your friend in most of the times. You need to know what you're doing to use hints, and it's not a good thing to force the use of any index or anything on the application code. So it's better to avoid using them on these application codes. So how would you overcome that if your application was developed to use the index, the hints to use and forced to use the indexes? You could also create a SQL rewrite for that, because there is no bind variable here. The query is static. It's just looking for sysdate -1 here on the order date. So it's the last orders grouped by county here. So yeah, it would work with the SQL rewrite equivalence here. So you could try other things here. So you don't like full table scan, you can try hinting in different ways using different index, but the CBO, the cost for that operation is still higher. So without hints, I would say it's the best way you can go. Or you can use parallel hints if you're not using autodoc, automatic degree of parallelism. You can force parallel. Parallel hints is something you can use if it makes sense for your application. So this is a report. So it's selecting the sales. I think it's the sales or something like that from the last 1 day, and I'm forcing here a parallel degree of 4, and it's running almost 7 seconds. So it actually got worse. So without parallel, it ran in 13 seconds. Oh no, it got faster. So it's faster, half the time. Anyway, I thought it would increase, but anyway. Yeah, you can also force the index, but with parallel, it got a little bit worse. So yeah, no hints would be better. SQL Tuning Advisor and SQL Plan Management. So you have a bad query here, or you have a query running that's not performing well. This is taking 1 minute and actually 1.5 seconds, not 1 minute, 1.5 seconds. This costs 87,000 to the database, and it's performing some full table scans and index scans. And we see that there are some parameters disabled here. I disabled them to avoid using some of the 19C features, which is the gather stats in conventional DML, and avoid using the dynamic sampling. So I'm telling the database not to use those features because I wanted to show you the database without any statistics. So this is the database without any statistics. This is actually the SOE schema without any statistics. And we can run the SQL Tuning Advisor. So the SQL Tuning Advisor will analyze our SQL statement, and it will suggest some stuff for us, some recommendations. So it's suggesting to create an index. It's suggesting to run the Access Advisor, which is another advisor. It's suggesting also to collect optimizer statistics for this table and its indices. So, and it's also considering, actually suggesting to accept one of the recommended SQL profile. So we could implement all of those and see how it behaves. So one thing to keep in mind here. So the cost here is 87,000. So let's keep that in our memory, in our buffer. And now we choose to, yeah, before implementing it, let's see the recommendation on that profile. So the estimated benefit by implementing that SQL profile is 42%. So it's considering that this will be improved using the SQL profile. The query will be improved by 42%. Okay, so that's fine. I like the recommendation. And now we see that what we see. So the original plan, when we compare the SQL Tuning Advisor profile with the original query execution plan, we see that the original cost was 87,000, and using the profile is actually 93,000. So where is that improvement of 43% that it was mentioning? This was because the SQL profile was not considering the statistics after gathering the statistics. So the original plan with the adjusted cost is 200,000 actually instead of 87. So it was actually considering 43% on top of the original with adjusted cost. So this is 43% improvement. Okay, so we implement everything. We created index, we created the SQL profile, and ran the statistics gathering and implemented everything. And actually the execution got even better. So we see only 22,000 on the cost here. So it got a lot better than what was estimated. And we see that we use that profile. So the profile was actually used for that statement. All right, so moving forward, I'm almost out of time here, so I'm just getting to the last topic, hopefully. So tuning in the application client. So what does that mean? So here I'm running just a SQL select statement on the orders table. So I'm getting all the rows and all the columns. Just to show a quick example. So the array size default of SQL Plus, which is the client I'm using here, the application I'm using here is SQL Plus. I'm running it select star from orders. It's taking 150 seconds to execute and doing more than 1 million network round trips. So once I increase that array size to 50, we see that it takes, instead of 150 seconds, it takes only 50 seconds, not 50 seconds, 95 seconds by increasing to the array size to 50. And the amount of network round trips was reduced from more than 1 million to just 360,000 network round trips. So we can see that it's getting better. So we are increasing the array size now to 500, which is 10 times more than the previous. So before it was 95 seconds to execute and fetch the data to our client. Now it's only 62, but we can see that this is not forgot the word, but this is not an proportional. It's not a proportional improvement. We increased by 10 times the parameter, the array size of the SQL Plus, but the time, the elapsed time of this execution didn't reduce by 10 times, right? But the network round trips, yes, that reduced by 10 times. So it's not always that you're going to change something that you improve on the same proportion of the parameter you're changing. So just one more example. Now we change it, the array size to 5,000, again, 10 times more. And we see that it also reduced by 5 seconds, and now it's performing only 3,000 network round trips. So we see that there is a lot less network operations going on. So it reduces some resources on the network, but it increases the resources of the application client, because increasing the array size on the application client will require more memory on your client. So if you're using a Java application, which already requires memory and a lot of memory, changing the array size or the fetch size in the Java code will increase the usage of memory on your client. So you need to balance that. So if you want to tune that on the JDBC connection, you can change the JDBC code on the set default role prefetch, the property default role prefetch when you get a connection with the drive manager. So, or you can change at the statement level instead of the connection level. You can change the java.sql.statement.setFetchSize. And you can also change the client or on the server by changing the send buffer size and receive buffer size and default SU size in the SQLnet.aura and TNS.aura. So it needs to match the OS send buffer size and the OS receive buffer size. And the default SDU size. So when you have larger SDU, you have more throughput. So it means less system calls, less CPU, but consumes more memory. So you need to keep that in mind. So there is no free lunch, right? You have to change one thing or the other and see how it behaves. So we are right on time. So on the conclusion here. So this is one thing, work together with the CBO. So don't try to be smarter than him. So have good database and schema statistics, have them up to date. Try to cooperate with the CBO by having good statistics on your data, and use the database features. I mentioned a lot of them. We couldn't see all of them that I listed, but there were a lot of features in this presentation that you can study and research on and test. So before implementing anything, test. So test before implementing anything. So that's what I had. Use the database features. And in case you want to be faster than what I showed, move to the cloud, right? That's what people say. So that's it for an hour. And do we have any questions?
Hi, Frank. Thank you for your presentation, for explaining a lot of features that we can use to cheat the database. And we have one question. What do you think that is better, advanced SQL rewrite or cost load SQL plan base?
They are, I think they are for different use cases, right? So advanced SQL rewrite, you will convert one SQL statement into another. So you get one SQL statement and you convert to a preferred one, let's say, as I showed here. And the COE, which is I don't remember the acronym, but the COE SQL plan baseline will get a baseline from your SQL plan management database, and we'll load that baseline to be the baseline of your SQL execution. So let's say you already had a good execution plan in the past, and that was stored in the, I don't know, somewhere in your SQL plan management database, and now you are just loading it back. So it's a different way to use both features.
Okay. We are checking if we have more questions here at the chat or at YouTube. Just some minutes.
I don't see anything in YouTube.
Yes, just one question. Just some 1 minute.
Okay, thank you for the time.
I think that we need to say thank you for your presentation and for your time to share the knowledge with the audience. And now it's time to the next one.